Hello students, myself Sarang Deshpande, the Mathematics Faculty of Global Education Center. In today's session, we are going to start with the first chapter of mathematics, that is the real numbers. So in class 9, we have already studied the number systems. In that we started with the classification of numbers. In this also we are going to first discuss the classification of numbers, and after that we are going to learn the first topic, that is the Euclid's division lemma. So as you can see, I have written it here as complex number. In class 9 we have seen the classification under real numbers, but with real numbers we have one more category of numbers called as imaginary numbers, and both comes together under complex number. Now let us understand what is a real number and what is a imaginary number. Real number, we define it as any number that can be represented on a number line, right? So we know that a number line is a horizontal line with 0 at the center. On the right hand side we have positive numbers, and on the left hand side we have negative numbers. So any type of number, if we are able to represent it on the number line, that is called as a real number. So then what is the imaginary number? For that I'll ask you one simple question. What is square root of 9? Square root of 9 is plus 3 or minus 3. Why? Because if we square 3 or if we square minus 3, in both the cases we get the answer 9. But if I ask you what is square root of minus 9, in that case we don't have the answer. We say that the answer does not exist. But yes, there is some particular answer for such numbers also, and such numbers comes under the category of imaginary numbers. But for 10th standard we are only interested in real numbers. But if there is a question, is real number or imaginary number a subset of complex number? Answer is yes, both comes under the complex number. Now let us understand the categories of the real numbers. First is the rational number and second is the irrational number. So what is a rational number? We say any number that can be represented in P by Q form, where Q is not equal to 0. Such number is called as a rational number. So any number, for example, if I ask you 6, is 6 a rational number? Answer is yes. Now you'll ask me why we cannot write it in P by Q form. We can write it because the denominator of 6 is nothing but 1, and this 1, that is the denominator, is not equal to 0. So rational number is any number that can be represented in P by Q form where the denominator is not equal to 0. It can be positive, it can be negative. What about 0? 0 is also a rational number because again its denominator we can write it as 1. So I think so now it is very clear that what are rational numbers. Now let us discuss what are irrational number. But before that you should understand the two types that are there in rational numbers. First type is called as the terminating rational number. Now what is the meaning of terminating rational number? If I ask you what is 10 divided by 5? 10 divided by 5 is 2. Correct? So this number is terminating somewhere. If I ask you 5 divided by 2, what is 5 upon 2? It is 2.5. Again this number is terminating after 5. So such numbers are called as terminating rational numbers. And the second type is non-terminating but recurring rational numbers. For example, if I ask you 10 divided by 3, what is 10 divided by 3? It is 3.33, where 3 is recurring, right? So such numbers also comes under the category of rational number. Then how to define the irrational number? Irrational numbers are those numbers which are non-terminating as well as non-recurring. Non-recurring means it won't repeat. For example, if I give you the example like root 2, last year also you have seen how to plot a root 2 on a number line. So root 2 is a classic example of the irrational number. Similarly, root 3 or root 5, these are also the irrational number. So you can note it down somewhere. Irrational numbers are those numbers which are non-terminating as well as non-recurring. In rational numbers we have two types. One is the terminating rational number and the other is the non-terminating but recurring rational number. Now in rational number I have written only three types here. First is the integer, second is the natural number, and third is the whole number. Now what is the integer? Any whole number that we can see on the number line are called as integer. So it can be negative again, it can be positive, and it can be 0 also. So I can say what are integers? We can say -3, -2, -1, 0, 1, 2, 3 and so on. So these are the examples of the integers. Similarly, then what are the natural numbers? Natural numbers are those numbers which starts from 1. So I can call it as integers, but it should start from 1. So that can be 1, 2, 3, 4 and so on. Then what are whole numbers? Whole numbers are those integers which starts from 0. So it can be 0, 1, 2, 3 and so on. So my next question is, can I say every whole number is an integer? Answer is yes. Every natural number is an integer? Again the answer is yes. So this order you should remember. So we can say every whole number is a natural number, every natural number is an integer, every integer is a rational number, every rational number is a real number. Okay. Now let us move on to the next topic, that is a Euclid's division lemma. Now what is Euclid's division lemma? First we'll go through the statement. It is written that let a and b are the two positive integers where there exist two numbers r and q such that you can write a as bq plus r. Also value of r lies between 0 and b. It can be equal to 0 but it cannot be equal to b. Now this statement seems to be very confusing. Let us try to make it easy. It is basically a simple division. Why it is called as a lemma? Because of this extra statement. Meaning of lemma is that already we have a proven thing and we are using it to prove something else. That is called as a lemma. So if I divide any number a by a divisor b, we get a quotient r and the remainder is r. So this value is called as the dividend. Similarly, this value is called as a divisor. Q is called as a quotient and R is the remainder. So in the previous classes also we have seen this formula that dividend is equal to divisor into quotient plus remainder. Similarly, I have written here that the dividend A is equal to divisor B into quotient Q plus remainder R. But what is the extra part you should understand is that the value of remainder always lies between 0 and b. So let us take one more example where we can try to show you the exact proof. Like if I divide 10 by number 4, we know that 4 2s are 8 and the remainder is 2, right? So what is the remainder here? 2. If I compare these two things, the value of r is 2, the value of b is 4, the value of a is 10 and the value of q is 2. So like a is equal to bq plus r, we can write it as 10 is equal to 4 into 2 plus the remainder is 2. Now let us think of this statement where 0 is less than equal to r, less than b. So 0 as it is, less than equal to r. What was r here? R is 2. And the value of b, what is value of b? It is 4. So the remainder will always lie between 0 and the divisor. This is only called as Euclid's division lemma. Now let us try to understand where it is used. So the first use you can see I have written here, it is used to calculate HCF of two numbers. So in the board exam you can see a particular question where it will be find HCF of any two numbers using Euclid's division lemma or Euclid's division algorithm. So let us try to solve one of the example. The first example you can see, question is find HCF of 20 and 6 using Euclid's division lemma. Now how to proceed with such type of questions? Such type of question you can expect it for 1 mark or 2 mark. If the values are bigger, then it will come for 2 mark. Like two numbers are there, 20 and 6. Out of these two numbers, you have to decide which one is a greater number. So 20 is greater than 6. So what we will do, we will divide the greater number 20 by smaller number 6. After that, you have to find the quotient. So what is the quotient here? You can say 6 3s are 18, right? So 20 minus 18 will give you 2. After that, you will write dividend as divisor into quotient plus remainder. So similarly, we have written here 20 is equal to 6 times 3 plus remainder is 2. In the next step, this divisor will be the dividend and this remainder will be the divisor. Like this dividend, you are going to transfer it here. So 6 will become the new dividend and the previous remainder will be your new divisor. So like 6, when you divide it by 2, we have 2 3s are 6 and the remainder is 0. So again we'll write 6 as 2 into 3 plus 0. You have to proceed till the step where the remainder value is 0. Once you get the value of remainder as 0, in the previous step, whatever remainder is there, that is called as HCF. Basically, what is the meaning of HCF? HCF stands for highest common factor. It is that digit, or you can call it as the greatest digit or the greatest factor for both the numbers 20 and 6. So your answer should be HCF of 20 and 6 is equal to 2. I hope friends you have understood these topics. In the next session we are going to continue with the same topics, few questions based on Euclid's division lemma. Thank you.